I think what they mean there, if you're trying to join statements together, you have to convert numbers to a string in order to have them work. Okay, so what are we doing here? We initialize score total to 10. We're printing out the string the total score begins at, and then the variable score total. Here, we are asking the user for input for a score, and we're presuming they're going to enter an integer. So we're nesting the input function within the int function. Int will change the text into an integer if it can. And then here we are trying to increment score total. This thing says it causes an error. Let's see. Hang on. Enter your score. No, that's not going to cause an error. That's just fine. Here it will simply add the new score to the old score. Let's change this back to the way it was in the slide where we have score total is 0, I'm sorry. And score, just input. Okay, here, this is the way the slide reads. Input, enter your score. Okay, and this is going to cause a problem for sure because we are trying to increment a numeric variable with text. Okay, so this is how the slide reads. So we get a runtime error because we're trying to add a text to a string variable to a number. Okay, so we can't do that. Okay, so here are 3 functions that are very common that you'll have to use with numeric variables. The first one tries to coerce the data to be integer. Second one will change it to a float or real number, and then round will take the number and it will try to round it to the number of digits that you indicate in the optional argument, second optional argument for using the round function. So give this a try. We've got a slide. We have a script here for this slide. Let's call it up. It's like this. Okay, and this first one causes an exception because you're trying to add a string to a number. Here we use the int function to coerce the string to be a number, and then it works just fine. So let's run this. Right, so you can't do this. You can't add text to, you can't add a string variable to a number. Get rid of all this. Works just fine because we change, again, you can change, in this case, you can change the string to a number because the string was 5. If you had real text in here, of course, it's not going to work. So the general rule is you can always change a number to a string, but you can't always change a string to a number. So how do you solicit input? Well, if you want it to be an integer, you just nest the input function within either the int or the float functions like this. Right, so we're having them enter some sort of number, we're asking for a number and we're making it explicit. We're saying, please enter an integer quantity. This line, of course, will just make it a text. So we'll have quantity will be, let's do this line. Okay. So if I pull this up,
Can we do this in one line? So just put the int before input.
yes,
Yeah, so we could do it that. I'm pretty sure I saw you do it that way one.
right. That's a lot simpler. So the easiest way to do this, of course, would just be do it like this. Enter an integer quantity. And we don't want to enter all that. We just want this. The quantity is 45. What happens if we enter something else like a real number? We get an error because it is losing information trying to change the real number into an integer. It doesn't simply truncate it. We get a runtime error, so you can't do that.
So a quick question, if we use the float command, but the input is an integer, a whole number, would that mess anything up or not?
I don't think it would, but I think it would give you, here, let's try it. I think it would print out the number, but it would give you a 0.0, if I'm not mistaken. Let's try it. So float like this, and I enter 45. Right. It returns it as a float.
All right, thanks.
Yep. Here's the int. Here's the float. That's the same thing. Okay, here's round. So we are having the user enter some value for it's an integer. We're having user enter something for gallons used, and it will accept either an integer or a float. We're doing a simple computation where we're computing miles per gallon, which is miles driven divided by the gallons used. And we are showing the unrounded number. If it's an odd number, then we're rounding it to 2. Here, let's run it. Okay, we want this to be something odd. So let's say 133 miles driven. Say gallons used, we'll say 17. Right, so miles per gallon, which is 133 divided by 17. We get this long, hairy real number. But if you round it off to 2, it does this. Okay. Okay, well, that's pretty simple stuff. Let's take a break, and then we'll come back and we'll look at some sample Python programs that use all this stuff. And then we'll look at your exercise for next time. Okay, so I've got 12:16. Let's come back here at 12:30. Okay. Let's finish up with this material, and then if we have time, and I think we will, let's move on to the material for the next week. Okay, so let's see, where were we? We were talking about, we just got up to the point where we were looking at sample programs. Which is here. Okay, so we've got a couple of, at least 2 sample programs that I want to look at for this chapter, and maybe we'll peek ahead and look at some for next chapter as well. This is the miles per gallon program. And actually, this is one that, let's take a look at this one. And I ask you to modify this for an exercise between now and next week. So here, let's pull this up. You've got this in your file. Right, so this is right here. MPG. Way, shove that over there. So again, this is a version, some sort of version of one we've looked at already. And it's very simple, really. So let's run it. So it asks you for miles driven, and we'll say, maximize this, say 150. Okay, let me kill this and start it up again. Kill that, start idle once again. Open MPG. There we go. It's tabbing over a couple of spaces. Say it's 150. 35.875. 35.875 gallons, and just simply calculates the miles per gallon and tells you buy. Okay, so what's going on here? Well, this is actually pretty simple. We have the shebang line at the top. This is appropriate if you're running on Windows for any program written in Python 3, followed by two print functions. First one just simply prints this title, and then the second one prints a blank line. In the input functions, we have two input functions that are nested within float. And we're using tab characters, escape characters over here to make it line up properly when the user is entering a number. Notice that there's two of them here and one of them here because this is indented a little bit more. So what happens is whatever number the person enters gets coerced, changed into a real number and stored in these two variables. Then we're simply just doing some calculations. We're calculating within the program MPG, which is miles per driven divided by gallons used. And then we're rounding it off to two places and printing everything back. Okay, so not much extra. We use an F string, again, with the tab escape sequences in there. Pretty simple. Now, notice this is not validating data. As we'll see in probably session 4, I'll ask you to write programs that catch errors that the user enter. This one doesn't. So, for example, entering text when they're asked for a number and so forth, you should catch that before it throws an exception. And it's not too hard to do. Okay, so that's pretty simple.